हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? upon a Kemena chain, this is Chandra Shekhar welcoming you all to the India's largest, best and your favorite live learning platform, that is BYJU'S Exam Prep. बताइए, am I audible and visible to everyone? Please do let me know so that we can start the session on time. So this is the GATE Champion series where we are going to discuss more than 500 questions from your mechanical engineering branch, and the difficulty level of all the questions will definitely be as per the difficulty level of your GATE examination. So if you are able to solve the questions here which are there in the GATE Champion series, no doubt you will be able to solve the actual GATE examination question with ease, with full accuracy. All right. So today's topic is all about the heat exchanger and radiation. I hope you have revised the topic of heat exchanger and radiation a little bit before coming to the class, because it is the numerical practice session, and if you have any doubt in any of the theoretical concept, you can always contact me through the comment section. All right. So please do let me know if I am audible and visible to everyone so that we can start. This is my introduction, quick introduction for those who are meeting me for the very first time. I am mechanical engineering graduate from IIT Delhi, having more than 10 years of teaching experience, quite comfortable in fluid mechanics, heat transfer, thermal and industrial engineering. All right. And those who have not joined me on the Telegram yet, I would request all of you to be part of my Telegram group, because once you join me on the Telegram, you will be getting all these things through the Telegram group, and you can always contact me through the mail ID also that is there on the screen. Hi Pratham, good evening. Abhishek, welcome. Welcome everyone. Shall we start? Please make some noise so that we can start the session. There will be some questions from the heat exchanger and some questions will be there from the radiation mode of heat transfer. And before we start, there is a quick update that on 6th of September, Ravindra sir will be taking a seminar or a workshop to know how you can crack the GATE examination. Very, very important for all the GATE aspirants, irrespective of your branch. So please do enroll yourself, do register yourself for the workshop, and he will be coming live at 8 p.m. All right. Telegram link chahiye smart. My Telegram link you want. This is the link of my Telegram group. Or in the description box, please go through the description box once. There are so many links provided to you which are important for you having the free content for your GATE preparation. So please go through the description box once. You will be finding the link to join the BYJU'S Telegram group, as well as you will be able to get the links for the workshop, and you will be getting the link for getting the free content for your preparation. Okay, there is the first question on the screen. Everybody, please give it a try. There, question number 1 and 2 are common data question from the heat exchanger. A counterflow heat exchanger is employed to cool 0.55 kg per second. It is a counterflow heat exchanger. Do you know how to draw the temperature profile for counterflow heat exchanger? The temperature profile will be something like this. Is employed to cool 0.55 kg per second Cp of oil from 115 to 40. This is 115 degrees Celsius. This is 40 degrees Celsius. Oil is the hot fluid. Mass flow rate is 0.55 kg per second. Specific heat is also given for the oil, 2.45. That is specific heat Cp. And then by the use of water, the cold fluid is water. Cold fluid is water. The inlet and outlet temperature of cooling water are 15. This is 15 degrees Celsius and 75 degrees Celsius. Very, very simple question. The question is very, very simple. Specific heat of water is given. Pp, you all know 4.18 kilojoule per kg Kelvin. What is the mass flow rate of water? Mass flow rate of the cold fluid. What will be the mass flow rate of the water? Can you solve it? Can you guys solve the question? If we apply energy conservation equation, whatever the heat lost by the hot fluid, that is oil, must be equal to the heat gained by the cold fluid. And the change in rate of change of internal energy of the hot fluid is equal to the rate of change of internal energy of the cold fluid. All right. कर सकते हैं क्या? M dot HCH TH1 minus TH2, that is the heat lost by the hot fluid, is equal to mass flow rate of cold fluid into specific heat of cold fluid into Tc2 minus Tc1. This is TH1, TH2, Tc1, Tc2. If you put the value, the only unknown is mass flow rate of cold fluid. Mass flow rate of hot fluid is 0.55 into specific heat 2.45. You can convert it into joule also, but because specific heat is there on the both sides, 115 minus 40 is equal to mass flow rate of the cold fluid into specific heat of the cold fluid is 4.18 into 75 minus 15. What will be the mass flow rate of the cold fluid? What is the answer you will be getting? Are you getting 0.48 kg per second or not? Are you guys getting 0.48 kg per second or not? Please give me thumbs up. 0.48 kg per second. Energy conservation equation. Option A will be the correct answer for this. Option A will be the right answer. Alright. Is this clear? The second part of the question is, what is the effectiveness of this given heat exchanger? What will be the effectiveness of the heat exchanger? Can you find out the effectiveness? To find out the effectiveness, what is the effectiveness? That is Q actual upon Q maximum. And how to calculate Q maximum? That is C minimum, minimum heat capacity into TH1 minus TC. Q actual, we have already calculated. This is Q actual. Actual heat transfer rate. So first of all, you need to find out C minimum. If we find out CH, that is mass flow rate of hot fluid into specific heat of hot fluid. Mass flow rate of hot fluid is 0.55 into 2.45. Mass heat capacity of cold fluid. Mass flow rate of cold fluid into specific heat of cold fluid. What is the mass flow rate of cold fluid? That is what we have already calculated, 0.48 into 4.18. So from here we can say CH is less than CC. So C minimum is equal to CH. Do you agree or not? Take the product of mass flow rate and specific heat and compare. So C minimum is CH. Then what we can write? Give me the answer if you are able to solve it. Q actually is CH into TH1 minus TH2. That is actual heat transfer rate. Then C minimum, that is CH into TH1 minus TC1. C minimum and CH are getting cancelled out. TH1 minus TH2 is 115 minus 40. The denominator is TH1 minus 115 minus 50. That will give you the answer. What is the answer? Are you getting 3 by 4? Effectiveness is 3 by 4. That is 0.7. Are you getting 3 by 4? 0.75. Good evening, Venkat. Welcome to the session. Are you getting option A or not? Please do solve and let me know the answer. The effectiveness of the heat exchanger, 0.75. Let us move to the next question. Question number 3 and 4. Good, Pratham. 3 and 4. Again, common data question. A parallel flow heat exchanger. Now it is a parallel flow heat exchanger. If you draw the temperature profile, the temperature profile will be like this. For parallel flow heat exchanger, has area as 25 meter square. Area is given as 25 meters square available for heat transformer. It is used for cooling oil at 250. The hot fluid is oil. This is 250 degrees Celsius. By using water available at 350. The cold fluid is water which is available at 25. It means TH1 and TC1 are given. Now assume the following data: mass flow rate of water. Water is the cold fluid. Oil is the hot fluid. Mass flow rate and specific heats are given. What will be the heat lost by the hot fluid if overall heat transfer coefficient is 500 watt per meter square Kelvin? If U is given as 500 watt per meter square Kelvin, then what will be the rate of heat transfer, or what will be the heat lost by the hot fluid? Heat lost by the hot fluid is equal to heat gained by the cold fluid. Can you just let me know how we will be able to solve this question? Can you just let me know how we will be able to solve it? The question is to find out Q, the rate of heat transfer, or Q actual. Whenever you are given, listen very carefully, it is very important. The question is very beautiful. Whenever the inlet temperature of hot fluid and inlet temperature of cold fluid is given, then we need to go for effectiveness NTU approach. Then we need to use the effectiveness NTU approach. There are three approaches in analysis of the heat exchanger. One is the basic energy conservation equation, first law. Heat lost by the hot fluid is equal to heat gained by the cold fluid. The second one is LMTD approach, and the third one is effectiveness NTU. So this is the cold fluid. Water is the cold fluid, oil is the hot fluid. First of all, you should find out C, that is mass flow rate of cold fluid into specific heat of cold fluid. Then you need to find out CH, that is mass flow rate of hot fluid into specific heat of hot fluid. If you take the product of these two, then what you will get CC is less than CH, isn't it? This product will be less than this product. So C minimum is equal to CC. Minimum is CC. So first of all, find out NTU, that is UA by C minimum. What is the value? U is given as 500, area is 25, C minimum is CC, that is 4500 by 3600. Put the values in their SI unit because it is given in kg per hour, multiplied by 4187. What is NTU? First of all, find out NTU and do let me know the value. What is the value of NTU? How much is the NTU? Number of transfer units. Are you getting NTU as 2.39? Are you guys getting NTU as 2.39? And then find out the heat capacity ratio, that is C minimum by C maximum, that is CC by CH, that is CC is 4500 into 4.187 divided by 13,500 into 2.5. The ratio, because we are interested in ratio, P will come out to be, are you getting C as 0.557? Are you getting C as 0.557? First of all, find out NTU, then the heat capacity rate ratio, P, and then effectiveness for the parallel flow heat exchanger is given by 1 minus e to the power minus NTU, 1 plus C on 1 plus. That is the formula. That is Q actual by Q maximum. Q actual is to be calculated and Q maximum will be P minimum into H1. Can you find out the effectiveness? Effectiveness will come out to be 0.626. That is equal to, or that multiplied with Q maximum, that is C minimum, that is 4500 by 3600 into 4187 into TH1 minus T1. That is, what is TH1 minus T1? 250 minus 25. 250 minus 25, that will give Q actual. That will give you the actual heat transfer rate. Please do let me know your answer. effectiveness will come out to be 0.626 multiplied by Q maximum. This is Q maximum. Then you will get the answer. Are you guys getting 736.78 or not? Are you getting actual heat transfer rate as 736.78? It is close to 737. Option B. Are you guys getting option B? Is this clear? बताइए, कोई कंफ्यूजन, कोई डाउट? किसी को कोई डाउट है तो बताइए. Is it all fine? All right. Let us proceed further then. What will be the LMTD for the flow? How to find out LMTD? Because we have already calculated Q actual. That can be equated with U into A into LMTD. Q actual हमने already find out कर लिया है. 737 something is equal to U is given as 500. Area is given as 25 into LMTD. You can easily find out the value of LMTD. What is the value of LMTD? Second part is quite simple. What is the LMTD? Are you getting 58.97? अगर आपको अभिषेक, अगर आपको इनलेट टेम्परेचर्स पता है फॉर NTU approach, effectiveness NTU approach, we require the inlet temperature of both the fluids. If we only know the inlet temperature of both the fluids, then we can go for effectiveness, because Q maximum, if we write Q maximum, that is T minimum into TH1 minus T. तो हमें TH1 और TC1 चाहिए for applying effectiveness NTU. That is the condition. Abhishek. 0.08 आ रहा है. यूनिट का ध्यान रखा आपने? वो किलोवाट में आया है, वो किलो जूल पर सेकेंड में आया था, किलो जूल पर सेकेंड. यूनिट में गड़बड़ की है ना. 737.7 किलो जूल में था. इंटू 10⁻³ भी करोगे तब आएगा, राइट? हाँ प्रथम, इंटू 10⁻³. चलिए, लेट अस मूव टू द नेक्स्ट वन. ये कौन बता पाएगा? नाउ some questions from the radiation. Question number 5. Shape factor is one of the important topic in radiation. Shape factor algebra and the analysis of the radiation. These are the two most important part of radiation. Determine view factor F2 to 1. This is the surface. This is surface 1. This is 2. Two is insulated from outside like this. This is how heat exchange will be taking place. There are two surfaces, 1 and 2. Determine view factor F2 to 1 for the long duct. It is a duct, cylindrical duct of given configuration. Can you solve it? This is an enclosure. This will become an enclosure. So according to enclosure theorem, F11 plus F12 is equal to 1. And do you agree F1 is equal to 0 because they are flat surfaces? 1 is flat. 1 surface is like this. They are flat surfaces. That is why self shape factor is 0. So F1 is 1. If we want F2 then it will be A1 F1 upon A2. That is reciprocity theorem. This is enclosure theorem. This is reciprocity. एनक्लोजर थ्योरम, रेसिप्रोसिटी थ्योरम। अब हमें A1 और A2 चाहिए। व्हाट इज A1? A1 is equal to, this is radius R, this is R, so A1 is equal to 2 into R into L, isn't it? The area of one plate is R into L, the area of another plate is also R into L, so 2 into R into L. What about A2? A2 is, if it would have been complete cylinder, then it would have been pi into R square into L, but because this is 90-degree angle, it is 90 degree, the angle is 90 degree, so it will be 3/4 of pi R square L. If you put the value of A1 and A2 in the given formula, F221 is equal to, F122 is 1, A1 is 2 into R into L upon 3/4, 3/4 of pi into R square into L. Is this clear? 1 R getting cancelled out with this 1 R, L is also getting cancelled out with L. It will be, sorry, वॉल्यूम लिख दिया ना, एरिया, सॉरी, 3/4 इंटू, हमें एरिया चाहिए पाई DL, 2 pi RL. It should have been 2 pi RL. Two would have been cancelled out with this 2. R would have been cancelled out with this R. L would have been cancelled. It will be 4 upon 3 pi, isn't it? It will be 4 upon 3 pi. What is 4 upon 3 pi? Are you getting option C? Option C. Enclosure theorem, reciprocity theorem, and areas correctly. If you are able to do that, then you will get the answer. That is 0.424 F221. Is this clear? Let us move to the next one. Again, question from the shape factor. Long inclined plates, point B is directly above the center of A. This is the center of A. Center of A1. This is surface 1. This is surface 2. And point B is directly above the center. Determine the view factor F221 for the above case. F221. We need to find out F221. Can you do that? What we will do is, we will take another surface like this to make it an enclosure. This is surface 3, let us say. This is surface 3. So from the symmetry, so this is an enclosure. From the enclosure theorem, we can say F11 plus F12 plus F123 is equal to 1. That is the enclosure theorem. We have taken another surface 3, join these 2 points. Now, because both are right angle triangle, both are having the same base, and both are having the common height, so they are symmetrical. F121 is 0 from, because of flat surface. अब यहाँ पे symmetry से whatever the radiation leaving from 1 and reaching 2 is same as the radiation leaving from 1 and reaching, sorry, the amount of radiation leaving 1 and reaching 3 will be same as the amount of radiation leaving 1 and reaching 2. From the symmetry principle, F122 is equal to F123 is equal to 1/2. From the concept of symmetry, surface 2 and 3 are symmetrical with respect to surface 1, isn't it? Surface 2 and 3 are symmetrical with respect to surface 1. Both are symmetrical because it is, this angle is same as this angle. They are making same angle. Their dimensions are also same. Same dimension, same orientation. So they will be symmetrical with respect to surface 1. If F122 plus F123 is 1, then F122 and F123 is equal to 1/2 each. Now we need to find out F221. F221 is equal to A1 F122 upon A2, that is reciprocity theorem, and F122 we have already calculated. Now we need A1 and A2. What is A1? A1 is 200 into L. L is the, let us say, length into the plane. What about A2? This is 100 because it is center. This is 100 mm. Vertical height is also 100 mm. So it will be 100 square plus 100 square under root from the Pythagoras theorem. A2 will be, that will be 100 root 2 mm. A2 will be equal to 100 root 2 into L. Is this clear? If you write A1, that is 200 L upon 100 root 2 L into 0.5 or 1 by 2, then what do we get? L getting cancelled out with this L, 2 and 100 are getting cancelled out with this. That is 1 by root 2 will be the answer. F1, 2 to 1 is 1 by root 2. What is the answer? 1 by root 2 or root 2 by 2. Are you getting 0.707? Option B. Question number 6, option B. 0.707. Is this clear or not? Is this clear to everyone? Please give me thumbs up. And do not forget to like this session and share to all your friends so that it reaches to maximum audience and everyone gets benefited. The next question, question number 7 and 8 are common data question. Question number 7 and 8, based on the data, this data. Consider an opaque means transmissivity is equal to 0, horizontal plate that is well insulated on the back side. There is a horizontal plate which is well insulated from the back side. The irradiation on the plate is 2500. What do you mean by irradiation? That is G is equal to 2500 watt per meter square, of which 500 watt per meter square is reflected. That is rho into G. Reflectivity will decide how much will be reflected. That is 500 watt per meter square. The plate has an emissive power of 1200 watt per meter square. Plate has an emissive power E, that is 1200 watt per meter square, and is at 227 degrees Celsius. T1 is equal to 227 degrees Celsius. You can easily convert it into Kelvin. Flows over, and air at 120 degrees Celsius. T infinity is 127 degrees Celsius. The air flows at 127 degrees Celsius over the plate with the heat transfer coefficient, convection coefficient, that is H, given as this. What is the net heat transfer rate per unit area? What is the net heat transfer rate? First of all, we need to find out Q radiation. How much net radiation will take place? That is J minus G. What in terms of watt per meter square? The radiation, the net radiation from the surface is J minus G. And what is J? That is E plus rho G. What is J? J is combination of these two. What is the radiosity? That is emission plus reflected radiation. That is J. Radiosity. And J minus G will be the net radiation heat transfer. So we can say 1200 plus 500 minus 2500 is Q radiation. That is the radiation heat transfer rate per unit area. And then we can find out Q convection. There is a convection also into the fluid. We can write convection from Newton's law of cooling. H into area, because we want Q dash. We are writing Q dash. H into delta T, that is 227 minus 127 watt per meter square. So Q net, or the total, will be equal to Q radiation plus Q convection. What is the answer? What will be the answer? Can you solve this? Q radiation is J minus G and Q convection is H into delta T. Add them with sign algebraic addition. because Q radiation will be negative. It is heat gain. Radiation will give heat gain and convection will give loss. Are you getting option A or not? Question number 7, option A. Question number 7, option A. Please do let me know if you are getting option A or not. 700 watt per meter square. What is the emissivity of the plate? Emissive power is given as 1200. Emissive power is given as 1200 watt per meter square. This emissive power can be written as emissivity into emissive power of the black body. That will be equal to emissivity into sigma into e to the power 4. Put the values. So 1200 is equal to emissivity into 5.67 into 10 to the power minus 8 into T, absolute temperature. What is the absolute temperature? 227 plus 273. 500 Kelvin. It will be 500 to the power 4. And find out the emissivity. What will be the emissivity? Question number 8. Are you getting option A? 0.34. Emissivity will be 0.34. Isn't it? Last question, common data question. 3 questions are sharing the same data. A small sphere, the diameter is 50 mm, that is D1, with a surface temperature of 300 degrees Celsius, that is T1, is located at the geometric center of a large sphere. This is sphere 1, this is sphere 2. So D2 is given as 100 mm with an inner surface temperature of 15, that is T2. Assume both spheres behave as black body. Epsilon 1 is equal to epsilon 2 is equal to 1. Now the question is, how much percentage of emission from the inner surface of the large sphere? The large sphere is insulated from outside and the smaller sphere is insulated from inside. So there is a radiation exchange between these two spheres. Like, how much percentage of emission? Do you agree if the body is a black body, emission is equal to radiosity? Because J is equal to E plus rho G. And for a black body, rho is equal to 0. So the percentage of emission from the inner surface of the large sphere is incident upon the outer surface of the smaller sphere. So it is actually the definition of shape factor. What is the shape factor? The fraction of radiation leaving a particular surface and reaches to the other. That is called as shape factor. So the emission means radiosity or the radiation which is leaving was the black body, and the fraction of radiation leaving from the bigger sphere and reaching on the smaller sphere will be how much? F221 is required in the question, isn't it? What we can say from the enclosure theorem, F11 plus F122 is equal to 1, and F121 is 0 because it is a convex surface. F221 from the reciprocity theorem, we can write F221 as A1 F122 upon A, and F122 is 0. What is A1? That is 4 pi R1 square. And what is A2? 4 pi R2 square. So it is R1 by R2 whole. Or we can write D1 by D2. So it will be 50 by 100 square. That is 1 by 4. F221 is 1 by 4. That is 0. 5 will be the answer. 25% is the fraction of radiation leaving the larger sphere and incidenting on a smaller sphere. I hope it is clear. F221. Question number 10. The next question, question number 10. How much percentage of emission means radiosity? You can call it as radiosity because it is a black body. Radiation leaving. F2220 नहीं होगा, F121 0 होगा. कॉनकेव के लिए सेल्फ शेप फैक्टर 0 नहीं होता प्रथम, कॉन्वेक्स के लिए होता है। क्यों 0 नहीं होगा? F222 देखिए, यहां से निकला हुआ रेडिएशन खुद को मिल सकता है, बट यहां से निकला हुआ रेडिएशन खुद को रिसीव नहीं हो सकता है, बिकॉज इलेक्ट्रोमैग्नेटिक वेव्स ओनली ट्रेवल इन स्ट्रेट लाइन। F121 will be 0, but F222 will not be 0. The radiation from the large sphere which is absorbed is equal to incident, क्योंकि black body है. The definition is again the same. The radiation leaving from the large surface and reaching, incident means reaching the inner surface of the same sphere itself. It means F222 will be asked. Now here F22 will be asked. F221 plus F222 is equal to 1. That is enclosure theorem. That is enclosure theorem. F222 is equal to 1 minus F221. That is 1 minus 0.25, 0.75, 75% of. Very simple. Question number 10 is very 75% will be the value of F222, 0.75. One more question, the last one. What is the net radiation interchange of heat between the two spheres? Because both are black, for the black surfaces, you can say Q122 net is equal to sigma into A1 into T1 to the power 4 minus T. Because both are black. Epsilon 1 is equal to epsilon 2 is Q122 net will be given by this. Right? It will be 5.67 into 10 to the power minus 8 into 4 pi R1 square. 50 mm is the diameter for the inner sphere. 50 mm is the diameter. So radius is 25 mm. So 0.025. 0.025. And you need to convert the temperature in Kelvin. 0.025 into T1 to the power 4. T1 is 300. T1 is 300. So it is 573. It will be 573. 573 to the power 4 minus 15. It means 288 to the power 4. What is the answer? Q122 net. To solve this, it will be F122 also, sigma into A1, because F122 is equal to 1. It will be sigma into A1 into F122, and the value of F122 is 1. What will be the answer? It will be, are you getting 44.9? Are you getting 44.9 or not? So the answer to question number 11 is D. So now I am giving you couple of questions for assignment. 45 bar hai? 45. It is close to 45. So there are couple of assignment questions. Try to solve this question and share your answer solution to my Telegram group. And if you have any doubt in any of the assignment question which I have been giving for all the sessions, you can just let me know through my Telegram group. Question number 12 from the heat exchanger. Then question number 13 and 14 from the radiation. There are 3 questions. Please try to solve these questions and share your answers, share your solution. So that is all from my side for this session. If you want to join my Telegram group, you can join me on the Telegram using the link which is there on the screen. Alright. So see you in the next session very soon. Till then, enjoy, take care, have a good night and a great career ahead. Thank you guys. Thank you very much for being part of this session, and do not forget to like, share and subscribe our BYJU'S. Thank you. Good night. Take care and Jai Hind.